Hello everyone. My name is Opu. Welcome to the 1 hour 3D design talk. So it's like I'm going to start a um, new discussion platform or a playlist in Upwork. So it's like we can discuss about it's like kind of like my experience I'm sharing. So it's like you can say it as a discussion, you can say it as a idea sharing, and also you can saying at kind of like delivering my so far experience I have gathered in the 3D workflow. So it's like you can take it as whatever you want. So the topic is based on the 1 hour, at least 1 hour duration of the 3D topic. So in this playlist, I will try to, try to bring several topics or several informative, kind of content. You should have a discussion with me, like you can, if you have any kind of questions or queries, you can do it in like you just mentioned in the comment box or whatever. So okay, so this is the first video of that of this playlist, actually the long show. So yeah, my topic is today's topic is introduction class of the interactive 3D design, which is the discussion one, by the way. My name is MD Wazullah Opu, and I am the interactive 3D designer, by the way. So yeah, so as you can see, my about, it's a very short about, actually. So my name is MD Wazullah Opu. I'm currently from country from Bangladesh, actually, and undergrad, I completed my undergrad is in 2011 from SMUCT, and graduation is my master's degree is in 21 from MMU, Malaysia. And occupation is interactive 3D designer at present, doing PhD in interactive 3D design. So I am actually pursuing my PhD course in interactive 3D design. Okay. So today's agenda, by the way, is kind of like an introduction of interactive 3D design. It's like, again, I'm saying it's like my understanding. It's not by the book or by the kind of like by the definition. So it's like introduction of 3D interactive design and discussion and question and answer. It's a very straightforward thing. Okay. So what is an interactive 3D design? Can you give some examples of it? Okay, what is interactive 3D design? So that is the first question of interactive 3D design. So yeah, I hope you can, but it's like that examples of interactive 3D design fields like 3D games. Okay, 3D games is obviously it's a form of interactive 3D design. Augmented reality AR, virtual reality VR, 3D simulation, okay, architectural visualization, obviously it should be interactive, urban design could be, research project could be, and medical could be. So these are the that I just roughly figured it out, that these are the scopes that interactive 3D design could penetrate in these fields, actually. So we see, yeah, we see, obviously we see from our childhood that 3D games is a very good form of interactive 3D design. Interactive 3D design is what is a 3D objects is interacting with the viewer, okay, interacting with the viewer. So that is the interactive 3D design. And then augmented reality, obviously that AR you have to interact with the 3D objects by kind of like medium of a mobile headset or a mobile phone or kind of like tab. Okay. Virtual reality, yes, obviously everybody knows what is the virtual reality and how it's function. Like you have a headset and you just use that headset to move around the 3D environment and all that. Then the category is 3D simulation. 3D simulation is another category that kind of like people used to learn something like kind of driving simulation, and kind of uh, flying simulation, that sort of things. Okay, so that sort of kind of like game, but it's designed for kind of like train some specific skills to you. So it's like 3D simulations. That is also another form of game, you can say. And also you can say it's like another form of interactive 3D design. Architectural visualization, obviously everybody knows that in a 3D industry, architectural visualization, like we see the typical renderings and animation, fly through animation as whatsoever. Okay, so there is a very good possibilities that in architectural visualization you have this sort of kind of like this sort of interactivity. You can move around, you can rotate and zoom in, zoom out, that sort of things. And also the urban visualization is also getting very popular nowadays, actually, that you can visualize not only a building but also a kind of like a complete city, 3D, and you should do everything possible, kind of in terms of the planning perspective. Okay. And there is another form of, it's like kind of like a research project. Yes, obviously, kind of like the example should be like kind of like space research, and also kind of like below the earth, or the below the surface level, that sort of research, and also the kind of chemical oriented research, and that sort of that the research containing risk factor could be visualized with the 3D simulation or 3D elements. So that is a possibilities for the interactive 3D to the penetration of that kind of fields. And also finally is I find that that medical, and there is a lot of, I mean kind of like a military also, that military simulation can be also interactive 3D, even for the military. There are some games like kind of like the soldiers can train by using that sort of games, by playing that sort of games. Okay, so these are roughly the criteria of the interactive 3D design. So it's like 3D games, augmented reality, virtual reality, and the 3D simulation, architectural visualization, infrastructure type of things, and also kind of beside that, there are a lot of examples you can find that interactive 3D design can be applied. But this is the roughly kind of like segments. Okay. Then we can talk with a little bit about the games, the 3D games, or a project. I put an oblique there. It's like a 3D games or a project. So it's like very similar, kind of like what makes a 3D game or project look good. What is your first thought in your mind? obviously it's everybody should say it's the graphics, right? It's the graphics. The graphics is the first kind of hit point, or okay, the first impression that people will understand about. Oh my God, the graphics is so good. The graphics is so bad. Even the person who doesn't have any very basic knowledge about that this game is good or this project is good or bad is like they're talking about the game, about the project graphics or games graphics, right? Okay, so I put two of the examples. Actually, by the way, this is from the Assassin's Creed two games example, like A and B. So they are from the actually the same game, Assassin's Creed, but you see the difference of the graphics, that how depth and how much detail can be achieved through a good graphics. Okay, so the first one is A is like very the when the Assassin's Creed first came. This is the first game of the Assassin's Creed, and the B is like Assassin's Creed Origins, from the Origins. By the way, I took these images from the as a reference from the Google. So I'm not actually advertising these games, but I'm just using these as a learning purpose to show the difference, that you see what how powerful is the graphics can be, what the graphics detail function can do. Okay, and how the computer graphics is gradually upgraded through the years, and through the it's kind of like an evaluation. Okay, in terms of graphics and in terms of detail and all that, and also the interactivity also. So it's like that. Okay, then you come to the same example. Another example is like from the Call of Duty, actually. So it's like Assassin's Creed, and also kind of like a Call of Duty. You see here that the A and the image A is like from the early versions of the Call of Duty, and B is one of the latest version of the Call of Duty. You see that the graphics is how much powerful is the graphics. Okay, that in the A is everything is looking like a bit dull, but in the B, like you can see the dirt, and you can see the trees, you can see the shadows, you can see the fogs and all that. It's looking very realistic. Okay, so it's all possible for obviously the detail of the modeling process, and also the detail of the graphics, and the computer powers actually is growing gradually. So on that period of time, that was the highest graphics quality back into 2003 or 4, when the Call of Duty or a Medal of Honor, this kind of legendary first person games came out. But nowadays you can see that this type of games has very good kind of like you see the dot, and you see the water, and you see the mud mixing and all that, you see the footprints on the mud. It's very much realistic. It's like you can't believe your eyes that how powerful could be this kind of games graphics and this kind of engines. Okay, so it's a revelation. I'm showing it in a two frame, but it's a revelation in terms of computer graphics between these several years. Okay, then Also, actually, in these games also, this is like a RTS game. So the same game, but the different. It's like a command and conquer generals game. Although the generals 2, I'm showing it's the B is from the general 2. General 2 is unfortunately cancelled by the developer, but General 1 is still around. I mean, it's still around. It's a very popular game. It's a command and conquer franchise game. But it's like again, I'm saying that I'm not advertising these games. These are for kind of like my it's I'm using these images from the very famous games for the learning purpose of this content. That's it. Okay. So you can see the general one is like, you can see the shadow quality, and you see the train quality a little bit of dull in terms of the B. In terms of that, you can see the detail of the train, you can see the building details, you can see the particles detail, you see the firing lights and all that, the smoke and all that. So obviously, even an untrained eye, they can identify immediately that, oh my God, the B is very good. Okay. You see the B is very good. Even you show a amateur, like people around, that they will see that the B, rather than the A, the B is very good. So these three examples actually coming from these are they are the legends actually, from this is the third person legends, the Assassin's Creed franchise, and also the Call of Duty is the first person, and this one is like kind of like RTS game. Okay. Actually, then what is actually going on? What is going on? What changes them? So the difference. What is the difference? Can you see the difference here? Actually, I'm showing it from my one of the my assets. Actually, can you see some difference? Like I am using the same asset, that same 3D model, and what is the difference? The difference is the texturing method. Okay, so the first one is only using the albedo color as one rough texture. No other maps is used, just one color texture. Just put it, and you just kind of like basic UV, and you just do it. That's it, that's done. Okay, the first image. But the second image is PBR texture, physical based rendering texture. Okay, PBR texture. You heard the term that very frequent, very often, that this is the PBR texture, this is the PBR texture, this is the normal texture. So you can say that the first one is from the normal texture. It's like quite simple, basic texture. But the second one is from the PBR texture. You can see the lighting, you can see the rustness, and you can see the kind of like these are kind of rusty. You can say the body parts, and also the glass. Every materials is kind of like looking very real, rather than the first one is you cannot tell, is this a metal, is this a kind of is this kind of a rock or whatever. But the second one, you immediately catch up the basement is from rock, or a brick, or a concrete, whatever. And the upper part, the box part, the box is metal. So it's like that. And then here is the again the another example, like this one is another example. Actually, the same 3D model, but in a different format. Same 3D model. I used the same 3D model, but in a different format, like Like you can see in the first image that this is like normal UV and normal texture applied, and you cannot see this is kind of like a wood or metal or whatever it's made of. But on the second image, you can see that immediately catch up in your eyes that these pieces are made up with metal. They are metal parts. Okay, so this is like the difference. Okay, this is like a difference what is the difference between the normal texture and the PBR texture. So this is what is going around. So this is what happens actually. This is the revolutionary change in the texturing architecture or texturing system. That is the the changing point. Okay, then the game assets or the assets or a game assets. If we can discuss that, what is an asset? Okay, what is an asset? The asset is, you can see it's like in the design field that assets could be divided into two parts, that 2D object and 3D object. So 2D object is like you can such kind of like animation, texture, sounds, they are 2D objects. 3D objects is like a 3D model or a 3D kind of content. They are separated basically in two parts, so 2D and 3D. So all of them are assets actually. So I put it in like you can call it, it's like interactive fields. Like you can, if you are creating a project, a VR project, a AR project, they are also assets. But if you are creating a games, they are also assets. It's the term is different, but the process is a bit similar. The footprints are a bit similar between these two. So that's why that is the difference of the assets. If somebody told you that what is the assets, so assets are everything that put in the game engine or everything that put in the game or in interactive projects. But the assets are two kinds, 2D and 3D. So obviously the 2D has the 2D properties, 3D objects has the 3D properties. Okay, so now what is a 3D asset? So 3D assets are like I said before, that the 3D assets are like kind of like the content that has such properties like length, width and height. Okay, it's like obviously it's like it should be a 3D model. Like you can see some of my reference, some of my images from my portfolio, that it's like you can see the tank, you can see the robot, and you can see the sci-fi object there. So it's like a prop object there. So they are actually the 3D model there. Okay. Then interactive 3D project creation flow. So what is the basic creation flow? What can be the flow? Okay, so it's like concept generation. It's like the basic part. It's like whatever your project you're gonna do, you have to generate your concept first, and then I'm not talking about the 2D process here. I'm because this playlist is about 3D, so I'm talking about 3D content generation, that sort of angle. So that's why it's like concept generation. So you have to generate, you have to come up with a concept that first what is you are going to do. Then it's like after the concept generation, there are a lot of process in the concept generation, like storyboarding and all that. I will cover it later. But the immediate after the concept generation, storyboarding and all that, then the 3D modeling part and 3D modeling part, and then 3D modeling is after the 3D modeling done, then the texturing. After the texturing, the next part is environment design, and then is the level design. Okay, so I put an oblique, that environment design and level design. So it's like there is a very thin difference between the environment design and a level design. We should discuss this more elaborately in the later videos. And then interactive functionalities. Interactive functionalities means that the what should do in an interactive, like if you press W, the player will go forward. If you press S, the player will go backward or something. A should go left, D should go right, or something like a movement or anything operational functionality is called the interactive functionality. And then finally, after that everything is done, then the project publishing means it's like you publish in a platform, like whatever platform, like is it a standalone, like installed in a PC or a laptop, or kind of like a web based or anything. So that is the publishing process. So basically they are 1, 2, 3, 4, 5, 6 steps you have to follow, from the concept generation to 3D modeling to texturing, environment or level design, interactive functionality, and project publishing. So they are actually the basic 6 category, but they are different topic. Okay, different topic we will discuss in a later upcoming sessions. Okay, yeah. Then what is the case is like 3D game asset creation flow. It's like 3D game asset creation flow. It's like a asset concept creation. So asset concept creation, it's like I said that a little bit of detail if I go, that a concept generation, it's fast. You have to draw. It's like kind of like a rough draw. So it's like you can draw its a rough part, like you can see some of my examples, that I put some top view or floor plan kind of view, and also some of the perspective view. That is the rough sketching. So it's like whatever your ideas, you just put it in a paper, like illustration. It's like basic illustration concept. Then with the basic illustration, there comes the concept art, and then you can generate a storyboard. It's like storyboard, it's the flow of your project. So that is the asset concept creation, or project concept creation, whatever you're gonna call. Okay. Then the second part is 3D modeling. 3D modeling is, everybody knows, and I don't have to explain it more. The 3D modeling is, you have to define that what sort of content, 3D content you have to do. There are a lot of 3D softwares like 3D Max, Maya, Blender, and whatever whatsoever. So you just use that softwares and come up with an idea and make your assets. Okay, make your assets. That is the basic 3D modeling part. Okay. Then after the 3D modeling, there is a process called UV mapping. UV mapping is a very vital things that you have to prepare your 3D model for the texturing. So for the texturing, in terms of the texturing, you have to flatten your 3D objects in a square box, like you see in the image, that you have to flatten the image. UV mapping is a very vast thing. We will discuss it later, but now you just need to understand the flows of it. So it's like you have to do the UV mapping. UV mapping is very essential in terms of achieving the texturing quality. It's like PBR. It's like a prerequisite for the texturing, like PBR texturing. So that sort of things is very important. So UV mapping after the 3D modeling, UV mapping is the next step. Somebody may say that UV mapping is as a part of texturing, but I think it's a separate part, because it's like a linkage between the 3D model and also the texturing part. Texturing is a quite separate things, but UV mapping is like processing of the texturing part. It's the initial process of the texturing part. Okay, then baking the texture. After the UV mapping, then comes to the texture baking. It's called the texture baking. So texture baking is there are a lot of softwares Substance Painter, Mari, and all kind of like Marmoset Toolbag, that sort of softwares. So typical PVR assets comes with typical PVR textures. It comes with these kind of maps like base map. AO means ambient occlusion. Metallic means it's like is your object has a metal property or not. Then normal map, then height map, then roughness map, and then emissive map. And all the maps are actually they are combined and make the complete PVR map and come up with the final 3D assets actually. So these 1 2 3 4 5 6 7 maps actually combining, and they are actually for the different purpose. Actually they have the different purpose. Base map has one, AO has one, metallic has one. So we have this sort of like base map is the base color. Ambient occlusion is for kind of dealing with the shadows. Metallic is, I told that metallic is for how metallic is your object or not. Normal map is basically normal, and height is like they are kind of like alternative, but normal map is basically very important. Normal map is basically responsible for the bumpness of the surface, how bumpy your surface, and how depth is your surface. That sort of things is can be tweaked by the normal map. Roughness is also that how is your surface, is it smooth, or if you is your surface is rough or whatever. That sort of smoothness or that sort of things is controlled by the roughness map. And emissive is like it's like it's responsible for the lightness, or wherever the light there is the emissive map. So that sort of thing. So these 7 maps actually doing their particular parts, and you have to have a combination of these maps to kind of like a final results of your project, of your asset. So that is the baking texture part. And then after the baking actually, then you can import it in a game engine, obviously. But you can have some prerequisite things, obviously, if you need some of the rigging things, like advanced animation, that sort of things, then you have to do that animation part. And then finally after that, finally you can import it in the game engine. So they are actually the game engine, but we call them as engine, but they are the software. So these you can see on the left hand side is the Unreal Engine, on right hand side is the Unity 3D. Okay, so actually these two are very famous in the game industry, and these two are kind of like a rival between each other. if you are in this field like interactive AR VR, that sort of things, you must know one of them or both of them according to your needs. So like Unreal Engine is very famous for kind of like a high-end game for a high-end projects like very graphically rich project. And also the Unity also is very famous for kind of like a AR VR kind of things, and all sort of things it's possible with the Unity and Unreal actually. So yeah, so after the process, from that process, from the concept generation and then 3D modeling, texturing, baking, texturing, and then finally after the animation apply, I missed the animation part. Okay, if you have the animation, then you put the animation and then come up with the Unity or Unreal. In terms of according to your project needs, you just come up with this. Okay, so that is the flow. And then is the kind of like an environment blocking. That sort of things is like I discussed in terms of the asset creation flow. Okay, the asset can be that type of flow, but what about the environment? So environment blocking, what is environment blocking? Environment blocking is like it's like the initial stages of the stage or your environment, like you see in these two examples, like boxy things, like you can understand that in the right part the artist tried to make some sort of castle and some sort of mountain kind of things, but he or she just put some sort of kind of uh, like like a low poly version of it. So that is I'm talking about, that he created the scale and he created the blocking fast, not detail. So it's not a good idea to put the detailed 3D model at present. You must create some sort of blocking at present. So the blocking could be for the 3D assets, or blocking could be for the environment also, or the level design also. So this is very important for your environment design or level design part, because it will increase your scaling capacity, that how big is your project is. So that sort of things, you just need to block them out by basic geometrical shape, like in the image. So that is the environment blocking, or level design blocking, or whatever. So blocking comes fast, and then after the blocking, then you can add the detail. Okay, like here is another examples. I took it from the internet. Like you can see the environment details. So two of the very famous games, like Red Dead Redemption 2 and also the Assassin's Creed Origin, you can see the environment details, but they don't put suddenly this type of details. They must create some sort of blocking at first, and then they actually gradually they put it like they're replacing the assets, and they put the design elements there. So blocking comes fast, and then you can achieve this type of reality, this type of things in your projects. If your projects want, you can see they are the open-ended games, so they're the huge project actually. And this type of things, and this type of games actually coming with the modular asset pack, because without the modular pack you cannot come up with this huge project. So that is another term actually, the modular asset. So it's like coming this one, that the modular pack is like that kind of like a building set or a Lego set. Okay, so you have to model a very small amount of part, and then through the small part you have to snap them, you have to link them, you have to connect them to create a big chunk of the model. So like in the example, one of my work, you can see that I created a kind of like a T-shaped laboratory, and I done it with a complete modular asset. You can see that the snapping parts are there. You can see the different windows type, different glasses type, and different room types. So I just snap, and then the complete things is just produced. So that is one of the example, shortest example of the modular asset. Later we will discuss about these sort of things more briefly. That what is the modular asset? Okay, and then okay, so now we come to the software requirements for the flow. So it's like yeah, so I divided the software, it's like into the three main group. So it's like a 3D modeling software, actually the 3D modeling and animation software. I forgot to do that actually. So it's actually, it should be the 3D modeling and animation software. So they are 3ds Max. By the way, I am the 3ds Max based. So yeah, some artist may be 3ds Max based, some artist may be 3D maybe Maya based, maybe Blender, maybe Houdini. So it doesn't actually matter that what software you are using. The matter is what you are producing. Okay, the matter is what you are producing, what you are capable of producing through by using that softwares. That is my belief, that is my understanding, that what you can produce. Because like with the 3ds Max, if I tell you to produce a chair or a table, I know that every artist, like 3ds Max, it's possible to make a chair. Maya, it's possible to make a chair. Blender, it's possible to make a chair. Houdini, it's possible to make a chair. Okay, so what you produce is the main thing. Software is just a tool. It's like my understanding. So it's like somebody may ask that, okay, I use Blender or I use Maya or whatever, but it's like kind of like a personal choice and personal understanding of the things. So I use actually 3ds Max. Okay, then again, baking and texturing softwares also. You have the Substance Painter, Mari, and also another software is Marmoset Toolback. One another software I use is XNormal. What is a very good actually baking software. It's like a bit old, but it's very effective in terms of the texture baking. So XNormal, they are actually the 3D texturing making software. And then finally comes is the game engine, like Unity, Unreal, and CryEngine. So the Unity, obviously everybody knows, in the game engine and the game community is Unity, and Unreal is very famous. And also there is another similar kind of game engine, but it's a bit it's a it's a bit kind of like um, what should I say? It's like CryEngine is, everybody heard of CryEngine, but unfamiliar, I should say. It's like unfamiliar to everybody, like in terms of the Unreal Engine and Unity. But yeah, they produce a very good examples, and it's like in terms of quality, they are the same. Okay, they are the same. Like you can produce, if you know the basics, you can produce the results, the similar kind of results, using the three of the engines. And there are a lot of engines out there, like I don't have to mention a lot of them, but Yeah, you can. There are also kind of like a Godot engine or whatever. I don't know, but these are the Unity and Unreal. They are the main kind of like a big boss of the 3D um, game engine related things. So basically, roughly, I just made the tree separation, and these are the software separation. So this is the things. And if I come up with a recap, like yes, we discussed about the interactive 3D, we discussed something, and then discussion of the 3D asset. So it's like a basic 3D asset creation and creation steps. We discussed about the steps and discussion of the softwares and implementation of the assets into the game engine, how you can import, what is the process and the environment design and publishing and all that. Okay, we actually skip the animation part, but later on we will discuss about this one. There are a lot of things we have to discuss, that what is the sound effect, how to use the sound and all that. Everything is related, so we will come in a later part. And then learning outcome, the basic understanding of the interactive 3D design and its workflow. So you see that by these things we can understand that what is the interactive 3D workflow, and how these kind of things can be produced. So I hope, yeah, any kind of Q&A, if you have any Q&A, I will be happy to answer them. Please mention them in the comment box. So it's like a request for me. It's like kind of like if you have any question, if you have regarding this topic, if you have any kind of discussion topic, or any kind of things you want to share, don't hesitate to comment. I will be very happy and share this one to your friends and loved one. Again, I'm saying this is not lecturing things. This is like sharing my ideas. I'm sharing my knowledge as kind of like somebody maybe getting help with this one. So it's like that. Okay. So I think I'm in a final stage, but not actually fully 1 hour long. But it's like I am in the final stage of my presentation part, or of my session part. So yeah, thank you very much. I think you will share this one to your friends and to your loved ones. And if you have any questions, or if you have any discussion, then I am all ears. You just mentioned in the comment box that this sort of things you want to discuss. Okay, yeah. And yeah, by the way, so then I'll have to then quit today's topic. Actually, I hope you like this one. So this one is actually very basic. I discussed about that what should be, and what is it about, what is going on. So it's like kind of like an evaluation of the 3D industry. It's and a main catching point is the upgradation of the texturing process. If your texturing is not good, your model is good, your 3D model is good, then I think half done. So it's like nowadays it's like kind of like you have to let, it's like what I see is like 50-50. So it's like 50% is effort you have to give your 3D modeling, concept generation, 3D modeling and all that, and 50% you have to give it in your texture design and all that. Every part should be synchronized. Okay, every part should be synchronized to coming with a good outcome of a project. So that is more acceptable. If you missed one step, if you missed one criteria, and you don't give too much attention to it, then the whole process can be interrupted. What I just said in this section, that yeah, if your model, if your concept is not good, then concept is like a root. Okay, concept is like a root. So if your concept is not good, then everything is bad. Okay, everything is bad. So you have to start from the beginning. You have to start from the beginning. So the concept, first of all, you have to have a very concrete concept. Okay, about your project, what you are going to do. So that is number one, the concept generation or concept creation. There is, in the concept creation, there are a lot of things like storyboarding, concept art, and blah 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 things. I will discuss it in later. So concept generation is very good. So it's not like that you have to be a Picasso, or you have to be a Da Vinci on the arting on the art, or drawing things. It's like roughly you can draw, just like the floor plan or something like that, roughly a sketch. You have kind of like a basic drawing skill that should be enough for your concept generation process. But the concept generation should be clear, so from your head to the paper. So that is the important thing. And then the 3D modeling. If your 3D modeling is bad, then everything ahead will be. If your 3D modeling is bad, then it's quite impossible to improve the quality in the kind of like in the texturing or animation part. So your 3D modeling should be resemble some sort of quality in terms of your final output. So what you are going to do, it should be up to that mark that your 3D modeling skill should achieve. Okay, you can see these images of some sort of sci-fi building collection, and also the sci-fi lab. So there are two types of examples I put from my work. It's like that. So from the concept, you have to have some sort of 3D modeling skill, that obviously, because your 3D modeling, people will see your work in a form of 3D modeling. So it's like visually appealing. So your 3D model should be reasonable, should be very focused, and should be in terms of have some quality outputs. Okay, and then this one is obviously a gate, that then comes the texturing. If your 3D modeling is so good, but your texturing is not, your texturing is your UV mapping and texturing part is not so good, then at the final stage you cannot have a good output. You cannot have a good output of your assets. So it's like all are synchronized, all are linked up. Okay, all are linked, like from your 3D modeling process, your things, they are all linked up. And then here is the baking and texturing process, and also here is the Unity and Unreal Engine process. So they are actually, what I'm trying to say, they are actually linked up in your every process. So there are several process. No process is actually less important. So you have to make a synchronized thing, from the concept generation to the level creation, and all that. It's from the animation perspective, all the things. Okay, so I think I am in final stage, so I think I should go now, and I will come again in the next topic, with the next topic, maybe a elaboration of this topic, or maybe in a different topic, but it's like discussion. It's like, you, if you like this one, please give a like to this one, and you can share it with your friends, and please, if you have any discussion, then put it in a comment box. And yeah, I will come again, maybe a sequence of this topic, and also maybe a maybe a different topic. Okay, so thank you very much. I will come again with another topic. Thank you.